As reported by Aviation Week on August 4, 2025, the South Korean company Korea Aerospace Industries, or KAI, confirmed during a South Korean Air Force conference held in Daejeon on July 28, 2025, that the upcoming KF-21EX Boramae will feature an internal weapons bay. This addition marks the most significant structural change in the KF-21 fighter program and represents a deliberate step toward achieving fifth-generation capability. Described as the centerpiece of the KF-21 Performance Improvement and Manned-Unmanned Teaming, or MUMT roadmap, the internal weapons bay will be capable of carrying Media Group, avionics engineers discussing fighter jet upgrades, KF-21EX with MUMT presentation materials, pilots reviewing internal weapons bay blueprints Atlas precision-guided bomb, such as the GBU-31J DAM, MBDA's Meteor long-range air-to-air missile, the GBU-39 small-diameter bomb, KAI's air-launched effects, and LIG-NEX-1's domestic long-range missile. The KF-21EX is also designed to serve as the central manned component in South Korea's emerging Next Air Combat System, or NACS, which is a distributed network involving manned-unmanned teaming, drone integration, and, multi-domain operations. This capability allows the KF-21EX to deliver heavy strike payloads against hardened targets such as bunkers without compromising low observability, a feature currently available only in aircraft like the F-35, Su-57, and J-20. From an aerodynamic perspective, internal storage reduces drag compared to external hardpoints, resulting in better fuel efficiency, higher top speed, and extended mission range. In combat scenarios, internal carriage improves energy retention after maneuvers and enhances flight characteristics by preserving the lift-to-drag ratio, especially during sustained turns or supersonic cruising. More importantly, it avoids increases in radar signature caused by external pylons, making the internal bay a core element in the KF-21's transformation into a stealth aircraft. Modern stealth jets, like the F-22 and F-35, employ this approach to maintain signature control throughout a mission. Although internal bays impose limitations on payload volume and require complex mechanical systems, they are, honestly, essential for operations in contested airspace protected by advanced integrated air defense systems. South Korea's KF-21EX is poised to challenge the F-35 in stealth by adopting core design elements of a true stealth fighter. Unlike the current KF-21, which lacks internal weapon storage, the KF-21EX adds internal weapons bays to dramatically reduce radar cross-section, just like the F-35's twin internal bays that hide smart bombs and missiles within the aircraft's smooth contours. While the F-35 has proven stealth through shaping, ram coatings, diverterless inlets, and low observable nozzles, which combined can make its radar signature smaller than a metal golf ball, the KF-21EX aims to reach similar levels by adding radar-absorbing materials, stealth-optimized exhaust, and conformal sensors. Although the F-35 benefits from decades of real-world stealth operations and software-defined avionics, the KF-21EX seeks to bridge that gap by pairing internal carriage with integrated sensor fusion and AI data links in a 5.5 generation architecture. In sum, the KF-21EX represents South Korea's leap toward domain-level stealth capability, using internal weapons bay design and signature management to approach the radar invisibility standards set by the F-35. To support this evolution, the KF-21EX incorporates a complete suite of structural and electronic upgrades. The canopy and radome have been reprofiled to reduce reflective angles, while radar-absorbent materials and radar-absorbing structures are applied across the fuselage and control surfaces. Stealth-optimized exhaust nozzles are included to suppress infrared signatures, and conformal antennas and embedded sensors are integrated to eliminate external protrusions. So, sensor systems here actually include an electro-optical targeting system, an electro-optical distributed aperture system, and an active electronically scanned array radar with automatic target recognition and non-cooperative target recognition. All of these sensors are fused together using high-speed optical and satellite-linked data links. The data is then processed by an AI-enabled mission computer, which provides targeting assistance, threat prioritization, and, flight path optimization. The KF-21EX is, really intended to serve as the core manned asset in South Korea's emerging next air combat system, which is a distributed operational architecture involving manned-unmanned teaming drone integration and multi-domain warfare. KI actually envisions the EX operating alongside unmanned platforms, such as the lowest coordinating strike missions, conducting escort jamming, and sharing sensor tracks in real time. While the KF-21EX performs escort jamming, accompanying drones will function as stand-in jammers, penetrating contested zones to suppress or deceive enemy air defense radars. MUM-T operations will rely on secure data link connectivity, AI-managed sensor fusion, and decentralized targeting frameworks. This distributed model will enable the KF-21EX and its drone partners to simultaneously attack dispersed targets, analyze threat vectors, and operate independently of centralized command structures. The overall system will include AI pilots, autonomous onboard management, swarm drone coordination, and potential integration of laser weapons. These capabilities are projected to define the NASS architecture by the 2040s, positioning the KF-21EX as its principal manned component. The KFX program began in 2001 with the aim of developing an indigenous fighter to replace the aging F-4 and F-5 fleets of the Republic of Korea Air Force. Following a decade of feasibility studies, propulsion assessments, and airframe design trials, the C-103 twin-engine configuration was selected in 2014, and full-scale development commenced in 2015. The first KF-21 prototype flew on July 19, 2022. According to KI's 2024 roadmap, the X will also serve as the base for a future sixth-generation fighter, potentially incorporating tailless designs, directed energy weapons, and autonomous AI systems.
Thank you for your support and for helping Intel Prime grow.